All right, welcome everyone. We are continuing on with Probability Notes Part 2. And so let's go ahead and get started. So you're on the bottom of page 2B is where we are picking up. And so as you see the slide, we're talking about two events are mutually exclusive or disjoint if they cannot occur at the same time. Okay, so there you go. And so this is where you might want to think about what are two events that you know couldn't possibly take place at the same time, such as if you're in a class, you can't get an A and a C at the same time, okay, in the same class. So that would be an example of an event mutually exclusive, and you guys can probably come up with some on your own, but you're basically looking at two things that cannot happen at the same time. All right, and so basically no outcomes in common. So the complement of an event is an event where it's the outcomes, I'm going to say the outcomes that are not included. Not included. And when I go through this example, I think it'll make a little more sense. And so the way you would write that is you'd write P of A prime, okay? Now, a way to get this formula is just doing 1 minus P of A, so 1 minus the probability of A. So an example here that I came up with is an example of a spinner. Okay, and so just sketching a little spinner and just going to make it into 4 pieces. And so I have yellow, blue, red, and green. All right, and so if I were to ask you what is the probability of getting a red, you would probably see that that's 1 out of 4. Now, what's the probability of getting not red? Okay, and so what you would see there is which ones are not red. Well, there's 3 that are not, so that would be a 3 out of 4. Okay, so that's what I mean when I say outcomes not included. Red is an included outcome, so a not red would be the ones that are not included. Now, of course, another way you can do this is you can do 1 minus 1/4. So if you know what that probability is and then you subtract, you get 3/4. Now, keep in mind, just counting like we did to get our 3/4 is fine if you don't have a lot of total possible outcomes. If you have a lot, this formula really does come in handy. So let's go on to the next slide. And so the probability that events A and B both occur is the probability of the intersection, is the word we're looking for here, of A and B. And the way we denote that is we do P times A intersect B. Okay, and some people, this is set theory, so if you've seen that before. Now, if you have events A and B are mutually exclusive, then what's the probability, or what do they have in common? Probability is 0 because they have nothing in common. And on the previous slide, I talked about that if they're mutually exclusive, they have no outcomes in common. So you should know that and is the equivalent of the operation of multiplication. So we're going to be multiplying to get our probabilities here. All right. So we're putting multiplication. So here you have 2 6-sided die. And so what I mean by that is you're going to throw one dice and then you're going to throw another one. Okay, just to kind of clear that up because I know it was a little confusing for me because I was thinking I overthought it. And I do that sometimes as a math teacher. And so here what we want is we want the probability of 4 times the probability of getting even. So on the first dice, when you throw it, the probability of getting a 4 is 1 out of 6. Well, we all know that because you're just throwing 1. Now, the probability of getting even on the second dice when you throw it is 3 out of 6. So when you multiply that, you're going to get 3 over 36, which reduces to 1/12. And that's how you get that. So you have to look at them, you're doing them separately. Even though there are 2, you're still doing them separately. All right. So now we're going to go on to the next slide. And again, feel free to pause anytime you need to get some, to hear it again or get some additional help. And remember that you can get that in class. So does the outcome of rolling one die affect the other? Well, the general answer is no. And if that's true, then you're looking at an independent event. Now, this would be something that you've probably heard in science class or previous math class where we talk about independent variables, where what we're looking at is a variable that, and it's usually your x-axis, and like time is an independent variable because it goes on no matter what else is going on. Okay, So then here are a couple of examples that we're going to do. For this first one, we're looking at, you're basically flipping 3 coins. So a heads, a tails, and a heads. Okay. And so there's a couple of ways you can do this. Okay, one is you can just list them because there are not that many outcomes. And so I'm going to list that for you because I kind of wanted you to see that. And so give me just a minute. And then here we're going to have tails, start off with all tails. And then tails, head, tails. And then tails, tails, head. And so if you look at that, should be all your possible combinations. And so where do you see a heads, tails, heads? Well, that's right here. And so you know that's 1 out of 8 because there were 8 total choices. Now the other way to get it is what's the probability of getting a heads when you flip a coin? Well, it's 1/2, and tails is 1/2, and heads is 1/2. And when you multiply all that together, you get 1/8. So you notice it's the same way. Now, there's nothing wrong with making this table. I think it's great, particularly if you don't have a lot of total possible outcomes. If you have a lot, this is definitely the way to go because nobody's going to want to list all that. So now, my question then for you is this an independent event? The answer would be yes, because what you get on the first flip didn't affect what you got on the second flip. So we're going to say that this is a yes. Now, when we look at this one, we're looking at a jar of 7 marbles. So 5 are green and 2 are red. Okay, and so what we have here is we have the probability of red and green. I think that's an and. Yes. I always forget that. I get that mixed up. Sorry about that. And so a possibility of getting a red and a green without replacement. Now that's the important piece in this particular problem is without replacement. So what that means is that you pull a marble from the jar and you don't pull it back. You don't put it back. Okay, that's without replacement. Replacement says you pull it, you look at it, and then you put it back. If you think about what we did with the Skittles previously, that was what we did. It was with replacement. So you pulled out a Skittle, you saw what color it was, and then you put it back in. Okay, so that does make a difference. And so here our probability of getting red is, where am I? The probability of getting red would be 2 out of 7. Okay, because you have 2 red and then there are 7 total. Now, since we're not replacing it, we no longer have 7, we now have 6. So the probability of getting a green is 5 out of 6. So you kind of have to be careful and you have to pay attention to whether it's replacement or not replacement. And so you have 10 over 42, and you can reduce it down. If you use a calculator, it's going to reduce anyway for you. Okay, and so now is this an independent event? The answer here would be no, because the second one was dependent on the first one because that's the reason that we went from 7 down to 6. So you do have to be careful and watch that. All right. So the next slide that we have, we're going to do the probability that events A or B occur. Instead of and, we have or. And so that's the probability of the union of A and B. And so what we're looking at here, the way you write that is the probability of A union B is equal to the probability of A plus the probability of B. All right, and so our OR is equivalent to addition. And so our example here is we have 1 die. Yes, okay. And if you throw it, what's the probability of getting a 5? Well, that would be 1 out of 6. And then the probability of getting an even number is equal to 3 out of 6, and we're going to add those together. So 1/6 plus 3/6 is 4/6. Reduced down to 2/3, but we're okay with the 4/6. So as you see, it was pretty simple to do. We just rolled and we just kind of wrote our probabilities down. All right. Now I have another example, 2 more examples, and so here again is where you're throwing 2 different dice. You throw one and then you dice and then you throw the other. So the probability of getting a 4 is 1 out of 6, and the probability of getting an odd number is 3 out of 6. And so when you add those together, again, you just happen to get 4 out of 6. Now keep in mind that your total possible outcomes for a standard deck of cards is 52. So you always kind of want to remember what your choices are. So this is our total possible outcomes. All right. Whoops, outcomes. There we go. Okay, so the probability of getting a 4 in a deck is going to be 4 out of 52 because there's only 4 4s in the deck. To that, we're going to add the probability of getting a 10, which is also 4 out of 52. So then we end up with 8 out of 52 before it's reduced. And so that's pretty much how that works. All right. Now, you still have one more instance that we do need to account for, and that's what happens when you have two things that can happen at the same time. And this one with the cards is a great example. So the way the formula works, it's P of A or B is equal to P of A plus P of B minus P of A and B. All right, so what you're looking at is the probability of a red card, which is going to be 26 out of 52 because half your cards in the deck of cards are red. Okay, and then the probability of getting a queen is only going to be 4 out of 52 because there's only 4 queens in a deck. Now, do the probability of getting a red queen. This is what I mean when I say two things can happen at one time, because the card can be red and it can also be a queen. And so when you do that, you're looking at 2 out of 52. So then we're going to take the 26 of 52 plus the 4 out of 52 minus the 2 out of 52. So 26 plus 4 is 30, minus 2 is 28 out of 52. And so there is your probability on doing that one. And that takes us to the end of the set of notes.